All right. Radicals, square roots, cubed roots, fourth roots, fifth roots, that sort of thing is what we're getting into today. Square roots are where we're going to kind of hang out in the quadratic section because square roots undoes x squared. So that's where we're going to be at right now. But eventually we're going to move into cube roots and fourth roots and higher powered roots out of that are radicals. A radical symbol looks like that. And then there's an understood 2 there if it's a square root. If it's a cubed root, there's a 3 that's there. If there's a 4 there, it's a fourth root. But what we're going to deal with today is square root. Okay? They don't ever put the little 2 index there, but that's what's there. And the next blank wants us to list the first 20 perfect square numbers. So what's the very first perfect square number? What's the next one? 2 is not a square number. 4 is, because that's 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. 36. 49. 64. 9 squared is 81. 10 squared is halfway there. 121. 144. 169. 196. 225. No. So 225 is 256, yeah. 16 squared is 256. 17 squared, now 289. 18 squared, 81 times 4, 324. And then 19 squared. I know what the last one is. I don't know what 19 squared is. I don't have it memorized. 361. And then 20 squared is 400. So the first 20 square numbers. Now, here's where my style of doing this kind of departs from some other people's style of doing this. Memorizing all those square numbers, not an extensive list there. It's only 20 of them. How many square numbers are there in the world? Way more than that, right? So if you do it by memorizing square numbers, you're never going to get to the end of things, right? You're going to have to continually memorize bigger squares and that sort of thing. So I don't do it that way. Some of you that had me for Algebra 1, you'll remember how I do this when I want to show it to you. It's, I think, probably a more universal way because when we do cubed roots, I do it the same way. When we do fourth roots, I do it the same way as I do square roots. We just look for different sets out of this. So simplifying radicals, when they're perfect squares, we take the square root of that number unless we don't know it's a perfect square. And that's where we run into problems. I have them memorized probably up to 16 squared is about as far as I go of just recognizing those numbers. But that isn't always the case. You don't always have a perfect square number that you're taking the square root of. It's nice when that's the case, and we'll use a calculator to help us with that, and we'll know some of these already. When it's a non-perfect square number, their idea of doing this is to break the radical down using the largest perfect square. Well, we have a hard enough time figuring out what number goes into another number, let alone what perfect square goes into it. So I don't look at it that way because if I look at the number 275 and I say, okay, what perfect square goes into that? I know 25 does, but is that the biggest one? And I've got to try all these other things, and I don't do it that way. I use a factor tree method for doing that. So if you had Coach Mack for Algebra 1, or you had maybe Miss Mainers or Miss Price, they may do it by perfect squares, and that's fine. If you do it that way, it's fine. I'm going to show you how I do them with factor trees, and to me makes more sense because it's easier for me to think of a number that goes into something instead of thinking is that the biggest perfect square that goes into that? Because it may not be, and I've got to check for that stuff. So I'm going to show you how to do that. And then for both cases, anything that's the coefficient is going to be outside, we're going to multiply times anything else we bring out. And I'll show you that as we do some examples here. So let's jump down there to those examples and work with those. And I'm even going to show you my style of doing this with the perfect square ones that we should already know. What do we know the square root of 49 is? Why? Yeah, because 7 times 7 gets us 49. Y'all remember doing factor trees when you're in elementary school where you did those little B's and what numbers multiply to be that? 49, the only way to break down 49 is 7 times 7. How many 7s are there? 2. We're taking a square root, so that's sets of 2. So a square root, if there's a set of 2, that set is the simplified part of that radical. 225. I may not remember that 225 is a square number, that it's 15 squared. I may not remember that, but it ends in a 5, so what do I know goes into it? 5. And I can divide 5 into 225 pretty easily. 225 divided by 5 is 45. And then 45 is 9 times 5. 9 is 3 and 3. This one has one pair of 3s and one pair of 5s. 3 times 5 is 15. So any kind of pair that you have comes out of the radical. If there's more than one pair, they multiply together on the outside. It's one representative from each set of 2. When we do cubed roots later on, cubed root has a little 3 on the outside of the radical. So we're looking for sets of 3 when we do cubed roots. When we do fourth roots, we'll be looking for sets of 4. So that's why I like doing it this way, because it carries over into the higher powered roots to think about. 144, maybe I don't know much about it, but I know 2 goes into it. It goes into it 72 times. And then 72, I happen to know that's 9 times 8. And that's 3 and 3. 8 is 4 and 2. 2 and 2. So I've got one pair of 2s, another pair of 2s, and then a pair of 3s. So that's going to be 2 times 2 times 3, which is what? 12. And then we have this 2 that was already outside. That's 2 times 12, which is 24. And that's what that simplifies to be. If you do it with square numbers and dividing square numbers into them, that's okay. When they're perfect squares like that, you don't have to do it this way. I mean, I'm honestly, I'm going to give you the advice that I would try those numbers under a square root symbol first. And if it comes out to be a nice even number, then use that. If it doesn't, then you've got to do some work. So let's get into some that are fractions real quick, and then we'll get to ones that don't work out so nicely. Square root of a fraction. If you remember doing this from either geometry or Algebra 1, the trick is to split it apart and take the square root of the top, the square root of the bottom. And we know the square root of 4 is 2, and the square root of 9 is 3. Numbers that small, I really don't do the factor tree on. On the 1 over 81, square root of 1 over square root of 81. Those are very familiar numbers to me. 1 over 9. Square root of 36 over the square root of 121, which is 6 over 11. So when it's square roots of a fraction, square root of the top, square root of the bottom, always. Okay. Now, excuse me, we get down there to example 7, 112. Well, we made that long list of the first 20 square numbers, and 112 wasn't on it. So this is where that factor tree method really comes in and helps us out. Okay, so what do we know about the number 112? What's it divisible by? 2, because it's even. So I'm going to divide it by 2. So I'll do 112 divided by 2. I get 56. So I've got it down to a number that maybe I know something about. What do we know about 56? It's even also, isn't it? 2 goes into it 28 times. And what do we know about the number 28?
Pardon the interruption. Tennis is canceled for today. Tennis is canceled.
7 times 4. And then we know 4 breaks down into 2 and 2. So we got 2 pairs of 2s and a 7 that's left over. So it's 2 2s on the outside. 1 for each pair. So here's a pair of 2s. That's that 2 right there. Here's another pair of 2s. That's that second 2. This 7 doesn't have a buddy, so he stays on the inside of the radical. And then we just multiply together the stuff on the outside. 4 radical 7. And that's the simplified form of that. Now, since there's a 4 outside, that means 16 would have went in a 112. I didn't know that. There's no test for if 16 will go into it, right? And most of us can't look at a number and decide and say, hey, 16 will go into that. I can't do that. And some of you may be able to do that, but I can't do that. So that's why the factor tree method, I think, kind of saves you from just guessing and checking all the time. You know some things about 112. You knew it was even, so divide it by 2, and then keep going from there. 245. What do we know about that number? 5 goes into it. I don't know much else about it, but I know 5 goes into it. So 49 times. And what do we know about 49? 77. There's a pair of 7s. So what comes to the outside? A 7. What's on the inside? 5. And that one doesn't need any multiplying done. It's finished. Anything that's in a pair comes to the outside. Anything that's not in a pair goes to the inside. All right, number 9, it's got the 5 hanging out on the outside already, so we know that that's going to be out there. But we got to break down the 72. So what do we know about 72? And say that again. 9 and 8 is one way. You could also divide it by 2. It doesn't matter what pair you start with. 9 times 8 works. You could do 12 times 6 would also work for that. Any pair of numbers that multiply to be 72 is legal there. And we know 9 is 3 and 3. 8 is 4 and 2. 4 is 2 and 2. I keep breaking the numbers down until they're all prime. So we got a pair of 2s. We got a pair of 3s. And then we got a 2 left over. 5 times 2 times 3 is 30. Radical 2. I can check to make sure that's right with my calculator. If I type in 5 square root of 5 and then hit second x squared 72, I get that decimal. If I look at my simplified version, 30 square root 2, it's the same number. So I can check to make sure that that's the right numbers out of that. So don't think we're completely abandoning the calculator to do this. The graphing calculator does not simplify radicals for you. TI does make one that does, but most people that I've seen that relied on that kind of stunk at the other stuff. So when it comes to the complex things, so be careful of that. All right, let's do number 10 there. Another one that's got a 9 hanging out in the front already, and the 45 there. What do we know about 45? 5 goes into it 9 times. 9 breaks down to 3 and 3. So we got a pair of 3s. We got 9 times 3, and then 5 left over. The final answer is going to be 27, radical 5. What do we know about the number 250? 10 goes into it because it ends in a 0, so that makes this one easy. 10 and 25, we know 10 is 5 and 2. 25 is 5 and 5. Oh, got a pair of 5s. What's left on the inside? Because that pair is that 5 that's coming out. What did not have a pair? 5 and 2. So those are both going to be left on the inside, and we would multiply them back together to get 5 radical 10 on that. So anything that doesn't have a partner that matches goes back to the inside, and it multiplies together with anything else that goes back on the inside. Things on the outside multiply together. Things on the inside multiply together. Always. Okay. 578. This is where I get to that point where I'm not checking square numbers, because 578 it just seems like a random number, and guessing which square number goes into it seems like an impossible task. But what do we know about 578? What number goes into it? 2, because it's even, right? So that's easier to do. So that's going to be 2, 8, 289. And then what do we know about 289? It was 17 squared. It happened to be a square number there. And so we get a 17, the 3 that's already out there, a 17 on the outside, 2 on the inside, 51 radical 2. Our final answer. So as we're doing these, we're going to get exact solutions, not just decimal approximations there. We want to get exact solutions as we're going through these. Okay. So just a refresher on simplifying radicals. You'll kind of, if you weren't great at that before, gets you a chance to get better at it now. We're going to use it some more tomorrow when we do complex numbers. We'll do some more simplifying radicals involved with that. So none of that's going away. And then we're going to use it as we solve by square roots today. Okay. So when we're looking at solving quadratics by square roots, major difference in this and what we did last week is that we do not need to get it equal to 0 first. Okay, the quadratic equation this is the form that we'll have: ax squared equals c. Only got an x squared in the problem. We don't have a plain x. That's the big difference. Okay, no plain x term. Okay, we're going to be using the square root property, and that last little if then there says if x squared is equal to n, then x equals plus or minus the square root of n. Okay. The steps that we're going to use, we're going to isolate x squared. So we're going to try to get x squared by itself for the problem. And then we're going to take the square root of both sides. We're going to simplify that square root, that radical. And we can't forget to put the plus or minus in front of that. Because if we take the square root of 25, we know the answer is supposed to be 5. But it also could be negative 5. Because negative 5 times negative 5 is also 25. So the plus or minus is always going to be there. Anytime we use the square root to solve a problem, you got to put the plus or minus in there. Okay. X squared minus 64 is equal to 0. This is one that we did last week by factoring. We're going to do it by square roots today. Okay. That would be a difference of squares if you're going to use factoring. We're going to use square roots today to solve that. So the first thing I'm going to do is get the x squared by itself. So I'm going to add 64. Once x squared is by itself, then I can take the square root of both sides. And on the side the number's on, I'm going to put a plus or minus in front of it so that I don't forget it. Always do it at that step so that you don't forget to put it in at the end. Okay? And then the square root of 64, it's a number we know, it's 8, right? So x equals plus or minus 8. Just like last week when we were solving the quadratics, how many answers did we find? Every time we found 2 answers, right? Positive 8 is one of our answers. Negative 8 is the other. We're still getting 2 answers. We're writing it like this just because it's shorter. We don't have to write it out 2 different equations. But that plus or minus 8, that's two different answers, positive 8, negative 8. All right. Number 2, they step it up a little bit. They make it a little bit harder. So what's our first step on that problem? Yeah, good job. Subtract 8. 7x squared is equal to 7. Is x squared by itself yet? No, got to get rid of that 7. So I'm going to divide by this 7. And that's going to be 1. Now x squared's by itself. I can take the square root of both sides. Plus or minus on the number side. What's the square root of 1? 1. Put the plus or minus in front of it. Two answers, positive 1 and negative 1. Not bad. See it number 3. It's our first step. Okay, so what do we need to do? Minus 5 from 21, so that's 81x squared equals 16. Divide by 81. And 81 doesn't go into 16 evenly. If I try to use my calculator to do that, 16 divided by 81, I get a decimal, and if I hit math, enter, it doesn't reduce any. Okay, so I'm just trying to reduce that fraction. If it won't, so I've got 16 over 81 there. Is x squared by itself? Yeah, so I can take the square root of both sides. Plus or minus on the number side. What's the square root of 16? 4. And the square root of 81 is 9. Good job. It ends up just being 4 over 9. Plus or minus in front of that. If you don't put the plus or minus, you're going to miss half the problem because you're missing one of the answers. So be careful of that. Make sure you put the plus or minus in front of that. Let's see about number 4. First step. Subtract 1. 8x squared is equal to 16. Divided by 8. Kind of boring. 16 divided by 8 is 2. It does go into it. All right, that's great. Now what? Do the square root. Plus or minus on the number side. Will the square root of 2 simplify? No, 2 doesn't break down any. It's a prime number, so I'm just going to leave it plus or minus the square root of 2. That's the exact solution out of that. Okay. What about number 5? Adding 9 on this one. Plus 9. 2x squared is equal to 64. Divide it by 2. And we thought we had a nice square number over there. We don't anymore. X squared is by itself, so we do the square root. And I'm just going to go off over here in the scratch area and do the factor tree for 32. 8 and 4, 2 and 4, 2 and 2, 2 and 2. So we've got 2 pairs of 2s and a leftover 2. That's going to be 4 square root of 2. Because remember, we're going to multiply one representative from each pair. 2 times 2 is the 4 that's in front. This 2 that's left over is the 2 that's inside. All right. Number 6. Minus 3, right? All right, and then you divide by 9 and get x squared is equal to 12. Take the square roots. And I'm going to do the factor tree for 12. 4 and 3, I'm going to use 6 and 2. And we should get the same thing at the end. Because that's 3 and 2. There's a pair of 2s. And a leftover 3, so that's 2 radical 3. I know I'm moving kind of fast. This is stuff you've seen before, so. And it's two-step problems. They're not real crazy hard. 7, 8, and 9 are a little bit more difficult. Still 2 and 3 steps, but different numbers. First step on number 7. Subtract 4. They mess us up by not putting in the descending order, which kind of makes it tough. So that'd be negative 81. Then I'm dividing by negative 3. X squared equals positive 27. Not a perfect square, so when I take the square roots, yeah, just letting it there. Thank you. Appreciate that. All right, and then break down the 27. I know 27 is 9 and 3. 3 and 3. There's a pair of 3s with a leftover 3. So that's 3 radical 3. A lot of times that one is the one that some folks mess up because there's so many 3s there. Kind of get twisted on what you should do with them. All right, number 8. They're a little nicer too on this one. At least it's in the right order. Divide by 5. Is that 60? Take the square roots. I'll break down 60. 10 and 6. 2 and 3. There's a pair of 2s. And then what's left on the inside? 5 and 3. So you multiply those back together to make the 15. That was several folks said too. Anything left over that doesn't have a partner goes back on the inside and multiplies back together. Number 9, they throw a fraction in the problem. Let's see what it does to it. Let's subtract 1. Negative 40. All right, which one are we doing? Yeah, if I divide by the negative 1/2, it's going to be a positive answer, which is good. Or I can multiply by the what of 1/2? The reciprocal. Either way is the same math. I don't care which way you do it. I'm going to write it just the way that I normally do it, is multiply by the reciprocal. That's the way I normally do it, but either way works. Dividing by negative 1/2 or multiplying by the reciprocal of negative 1/2, which is negative 2. Either way is the same thing. Makes the same answer. Makes it positive 80. And then I do the square roots. And with 80, it's what, 8 and 10? Yeah, 4 and 2, 5 and 2, 2 and 2. So I've got 2 pairs of 2s. Plus or minus 4, radical 5. Questions about that? It doesn't get much more complicated than that today. We'll get a little bit more stuff in, and when we start adding in complex numbers, which is a new thing. And I will encourage you, graphing calculator will be handy tomorrow when we do the complex numbers, because the graphing calculator can help us check some of our work with the complex numbers, because it actually can do some complex numbers. It just can't do square roots. I'm sorry. We're gonna have time to finish this in class today. You got about 43 minutes left. You'll be able to get a lot of this done. Ask questions if you need to. Excuse me.